Welcome to this tutorial. In this tutorial we are going to learn about firewalls. With regard to the functions of a firewall and how to configure the firewall, let's start with the functions and how to configure a firewall in general, because there are so many different brands of firewalls. So we are not going to touch on any particular firewall, but we are going to speak about how to configure a firewall in general, the firewall policies that enable my voice business to be connected with a SIP trunk. To a SIP provider. So that a user on my voice business can be able to make a successful call to somebody who is sitting in the world outside the organization, and have the call be successful with the audio both ways, with full audio both ways. So this tutorial, this video is going to discuss exactly what we need to do with our firewall for the SIP trunk to work properly, for us to achieve a good working SIP trunk connection. So what does a firewall do? A firewall is like a guard. A firewall is like a security guard. So its role in an organization, if you have a firewall, suppose this is our firewall and this is the world. Let's define the world. Let's denote the world by the word internet. Internet means the world. We don't trust the world because bad people sit in the internet. So we don't trust the internet. Bad people stay in the internet. So in order to protect our organization from the bad people living in the internet, we deploy a firewall. The role of the firewall is to inspect what is coming from the world into our organization to our users. Then we want to know if what is coming, if we want to allow it or to disallow it, which means we block or we drop. If we see anything coming from the internet wanting to go into our organization, we can. If we don't like it, we can drop it, or we can block, or we can disallow. And also, this is for incoming traffic from the world, incoming. But we also have our users inside the organization, inside the company. These users can also go into the world, into the internet, to the internet. They can also go to where we don't want them to go. So these users of ours who are inside the company, they might go into the internet to sites that we don't want them to go to, because probably those sites are full of maybe viruses, or it could be they will go and watch things that we don't want them to watch, maybe. So they can also be able to utilize the firewall in blocking or disallowing our users from going out to certain sites on the internet. So the firewall is there to do that, but by default, at a high level, we can say by default the firewall wants to block by default. This is general. This is at high level. By default, the firewall wants to block all incoming traffic, from the internet, because it doesn't trust the internet, and it wants to, by default, it wants to allow all outgoing traffic to the internet. So when we first connect our file, it's going to block everything that comes from the internet, and it's going to allow everyone to go to the internet. Then we can come in and put a policy. Maybe our first policy is to say, let us allow our email traffic to come through. Now, if something comes through, if it's an email, we are going to let it to come through. Or we can say number 2, let's allow maybe Teams to come through. This is at high level, so that if somebody wants to have a meeting with us through Teams and they call us, it should be able to come through. So we'll be building policies as we go. And then we can also come in and say, instead of allowing all the traffic to go into the internet, let's start blocking YouTube, for example, during working hours. If somebody wants to go out to YouTube, as our policy, probably policy number 3, we are going to say we are not allowing you to go and watch YouTube during working hours. So if a user wants to try and open up YouTube, is going to fail. So that, just at high level as an example, this is what a firewall can do. And also the firewall is blocking when we are doing our policies to block or unblock. Policies allow the firewall, it allows the firewall to inspect, it allows the firewall to inspect packets, to inspect traffic, or that is going through the file, in and out, to inspect, so that if it meets a certain criteria, or if it does not meet a certain criteria, take an action. So we are telling the file that inspect incoming and outgoing traffic to meet a certain criteria, or if it doesn't meet a certain criteria, if it does match a certain criteria, can you take this certain action? So the kind of a criteria that you might set as a policy is to say, based on source traffic, source and destination. That is to say, can you inspect inbound traffic? Probably we want to do a policy for inbound traffic. If you see traffic that is coming from an IP address, as an example 8.8.8.8 as a source, and it is destined to our network, our LAN 168.192.168.1.0, allow as a policy number 1. You can also have as an inbound policy to say, if you see any incoming traffic coming from this IP address, let's say .92.92.92 destined for our probably our email server. Probably it's 168.1.200. Block, do not allow this to come through. But if it is coming from this same IP address and it is going to 192.168.1.100, allow it. As long as it is going to 1.100, allow it. So we are saying we are creating a criteria or a policy based on number 1, source and destination IPs, or number 2, we can base on IP protocol, which means, for example, TCP, UDP, ICMP. As an example, we can say if this is the firewall and there is something that is incoming into our firewall and it is a ICMP packet, no matter where it's coming from, it could be coming from anywhere. As long as it is ICMP, we must block it. We must disallow it. No matter it is going to any IP address, we must disallow it. Or we can also base on ports. We've got well-known ports like port 80, for example, which is HTTP. We've got port 443, which is HTTP. We've got port 69 as an example. We've got so many different ports. We've got port 21, which could be SSH, and we've got port 22, which could be whatever. So you need to go and research on these ports. So we could go to our file and say, if you see an incoming traffic which is a ICMP, which is probably, let's say, HTTP, which is on port 443, you can drop. So moving on, how does this tally to a SIP trunk? How does the firewall tally to a SIP trunk? How does a firewall relate to a SIP trunk? So when we have a SIP trunk, we are going to have a firewall, and the firewall, let's do this. We are going to have a firewall, and the firewall has a public IP address on the external interface. Which we shall call the 1. And this public IP address could be, in our case, we gave it this IP address 167.168.1.2. So this is our external interface of the firewall, which connects us to the internet. And then here we've got our LAN. where our devices or users reside. This is where we are going to have our computers, our telephones, our Mitel My Voice business on the LAN here. So what the firewall is going to do with the public IP address that is sitting here, it is going to say, if this was a computer, for instance, for example, this was a computer, this is a PC, it's also connected to the LAN, and it has an IP address of 192.168.1.11. If this PC wants to go to the internet, it's going to look for its default gateway, which in our case is 192.168.1.254. And this default gateway is the one which can send the traffic to the internet. So it does this by sending this out of the external interface of the file. The external interface, which is what we can call the one, which will be this, where we've got a public IP address, which is 167.168.1.2. So because we are going into the internet, this IP address of the PC 192.168.1.11 cannot be routed on the internet because it is a private IP address. So we have to change it into a public IP address by NATing on the firewall. So the firewall is going to NAT here. So this is probably, it means NATing. It's going to change this into, so we are going to have 192 being NATed to 167.168.1.2. So we are going to have port translation. We are going to have ports being NATed here so that we can be able to talk to the internet. So if we have our PC here with this IP address 192.168.1.11, it has a source, it has an IP address and a port, which is, this becomes the source, and is going to a destination which is outside. It's probably it wants to go to 8.8.8.8, maybe port 69, maybe it's going to, it's a DNS server and it wants to ask for a DNS resolution. So it's going to come here onto the firewall and it's going to generate its port, so that here we've got a port, probably it's port 6000 and it's TCP protocol. Here the firewall is supposed to change this IP address from being 192.168.1.11 port 6000 to 167.168.1.2 port 6000, and then keeping the destination, which is 8.8.8.8 port 69. Then it's going to check with the policies. we've got 192.168.1.11 who is using port 6000, who wants to communicate with 8.8.8 on port 69, and this is, we can say this is TCP. So we are going to check, is there a policy which does not allow this IP address to go out into the internet to this IP address? We can say no, there's no such policy. Then it's going to say, is there a policy which is disallowing port 6000 from going out to port 69 TCP? And then again, if the answer is no, then this outbound traffic is going to be allowed. It's going to be allowed through from our PC. It's going to be NATed, and it's going to go to, suppose this is 8.8.8.8. This is going to be successful. But then this 8.8.8 is going to send a return, is going to return the answer. So when it comes, the response is going to be the opposite. 8.8.8.69 is going to be the source. Remember, it was the destination. It is going to be the source. And this 192.168.1.11 port 6000 is going to be the destination. But remember, it has been NATed when it went out. So the destination is going to be the public IP address of the firewall, 167.168.1.2 port 6000. When the firewall receives the reply, it's also going to check, do I have a policy for inbound traffic which allows 8.8.8 to come through? If the answer is yes, allow it to come through, it's going to pass on the traffic to the PC which originated the traffic. If it is such that there is a policy that blocks 8.8.8 from passing through the file onto the LAN, onto that PC, the file is going to block this. And then this PC now is not going to get its response, and is going to fail to resolve. If it was asking for what IP address is youtube.com, and it was asking 8.8.8, and then there's no response that comes, so it doesn't know what is the IP address to connect you to youtube.com, so it's going to fail to connect to YouTube. So let's drill down this and apply it to SIP trunk. So a SIP trunk, if this is a SIP trunk, let's say this is a SIP trunk, the SIP trunk, and say, let's say it's a peer to peer, which means here we've got our provider on this other end, and the IP address of our provider 168, let's say in our case 167.168.1.11. This is the IP address of our provider, being the signaling IP address. Signaling is responsible for call setup and tear down. So when it's signaling, we know that it's going to go to port 5060 or 5061 if it's TLS. But let's concentrate on port 5060. And on this other left side of the SIP trunk will be our Mitel controller. Which has an IP address. In this case, the IP address is, okay, let me change a color so that this is visible. This is visible. Let me use green here and put up a SIP trunk here. This side is the provider, and this is the IP address of the provider, and the provider is on port 5060. And on this side, let's extend this to here. On this side is our Mitel controller, which has this IP address and also port 5060. So for this trunk to come up, for this trunk to be active, to come up, to be active or to register, number one, because we are going to the internet, 192.168.1.2 cannot be routed on the internet. We have to make sure that it is NATed on the firewall to the public IP address of the firewall, which is 167.168.1.2 here. And then we have to make sure that we do port forwarding for inbound traffic, because our SIP provider is going to ask to peer with this IP address 167.168.1.2 port 5060. This is going to be, and then when it reaches the file is going to say, do I have a policy that allows port 5060 to be allowed through for the destination of 167.168.1.2. But wait a minute, 167.168.1.2 is me, the firewall. So I have to also look into a policy, which is a port forwarding policy, which says if you see an incoming traffic for your IP address 167.168.1.2 but on port 5060, can you 167.168.1.2 port 5060, can you remove this? Can you remove your IP address and replace it with the IP address of our Mitel controller, which is 168.1.2, and keep the port as 5060. So number one, if we don't have a policy on our file which allows port 5060 to come through from the provider, and then the public IP address of the file being dropped and being replaced by the private IP address of the Mitel controller, which we call port forwarding, the trunk will not come up, it will fail. And also, outbound wise, we should allow our firewall to pass through traffic from 192.168.2 as the source, going to our provider as the destination 167.168.1.11, for example, in our case. And then it should be able to tell the firewall that remove this IP address, the private IP address of the Mitel controller, and replace it with your IP address for the external interface, which is 168.168.1.2, and keep the port as 5060 for the source and send it to the provider. So if the firewall doesn't allow that, it means it's going to fail. So we want the firewall to allow 192.168.1.2 port 5060. We want the firewall to change this to its 167 to its public IP address 1.2.5060, and then allow it to go to the provider. This was the Mitel. To go to the provider signaling IP address, which is 167.168.1.11 on port 5060. And it should be, the firewall should also be given a policy to allow the return traffic from the provider on the same port, and then the firewall should be able to pass through the return traffic to the Mitel controller by removing its IP address and replacing it with the IP address of the controller and letting the port number to be the same. So if the firewall doesn't allow this through, the SIP trunk will fail to come up. We can be able to, we will then, if the SIP trunk doesn't come up, we are going to be unable to make outgoing calls. Or we will be unable to receive incoming calls because our trunk is down. So, number one, just to summarize, our firewall should be able to do a port forwarding. For this public IP address on the file, should be able to forward port 5060 to the Mitel controller port 5060. And it should be able to allow inbound traffic and outbound traffic to the service provider as source and destination, which interchanges. So that's number one. Let's move on to number two. So if this user makes a call, okay, let's do this. So this is to do with policy number one, which we said we should be able to allow traffic on port 5060 being port forwarded to the controller. If we don't do that, we are going to, if our firewall is dropping those packets or that traffic, we are going to have a challenge where the calls will fail. Okay, let me switch to a different color here. In this scenario, we've got this user who wants to make a call to the bank. This is the account manager here at the bank. So this user is going to signal to the Mitel that it wants to make an outgoing call, and Mitel is going to send the signal to the provider. This is signaling. In the form of an invite. And the provider is going to extend the invite to the bank. So for this to be successful, this signaling for this invite to be successful, the firewall should allow this IP address of the Mitel 168.1.2 port 5060 outbound to the IP address of the provider signaling port 5060, and this is protocol UDP, and the firewall should be able to change this 192 at the exit interface to the public IP address of the firewall 1.11 port 5060 here. So if the firewall fails to do this, if it fails, then this call is going to fail. Also, if the firewall allows this traffic to go through, if it allows it, and then the provider is going to send a response to the invite, and then that response, if it's not allowed to come through on the firewall, if you don't receive a response, the call is going to fail, the call setup. So we must make sure on the firewall that we allow this outbound of UDP port 5060 and its return. So if you allow and then everything is successful, it is allowed, the call is set up, and then once the call is set up, the user is going to create a path from the phone itself, from the device, to the provider's media IP, to the account manager at the bank. So this is for media. Protocol is RTP, which belongs to the UDP family, like this. This is RTP. So RTP, let's say this phone was 192.168.1.11, and then it's going to pick from the RTP ports of Mitel, which is from 50,000, 50,000 to 50,511. Let's say it picks port 50511, so it's going to use port 50511 here, and here we are going to have the media IP address, which is probably 167.168.1.12, and it's also going to select ports from 10,001 up to 65534. Let's say it chooses 65534. So we are going to have these two should be able to talk to each other through the firewall. So the firewall, number one, we said you should do port forwarding. You should be able to port forward port 5060 both ways without blocking, so that signaling can be successful. Then when signaling is successful, the next thing is going to be the media should be successful. If the media is not successful, we are not going to have audio, because the media path is what carries our audio. So during the signaling, there were SDP messages that were sent across to each other. This microcontroller said, I am going to create an RTP path with this IP address and this port. And also the provider told Mitel that it is going to create an RTP path on the other end with this IP address and port 65534. So the firewall when it should be able to allow this port and this IP address from the provider to come through the firewall. If it blocks this, there's going to be no audio coming back from the provider. Suppose the firewall is allowing this to come out and reach this banker at the bank. The bank is going to be able to hear the caller. But when the banker replies, the reply is going to be blocked by the firewall here, and there's going to be one-way audio. The user who is here will not be able to hear the reply of the banker. So there is going to be one-way audio. Or if the firewall blocks this from outgoing and allows traffic from the banker to come here, the user is going to hear the banker, but the bank is not going to hear this user. And it's also going to be one-way audio. So what should happen is that the firewall should be able to allow outbound RTP, which is UDP, ports 50,000 up to 5511 from the LAN source. The IP addresses, all IP addresses of the telephone IP phones. If this phone was 192.168.1.11 and our controller is 192.168.1.2, we should allow all the IP addresses 192.168.1.3 up until 254. We should be able to allow them as source IPs together with this range of RTP ports and this range. We should be able to allow them outbound on the firewall as protocol UDP. They should be allowed to go out. So we are saying, in our case, allow 192.168.1.3 up until 254 using ports 50,000 up to 50,511 as source, and protocol UDP should be allowed outbound to destination provider media IP. In our case, it is 167.168.1.12 and to the destination ports to 10,001 up to 65,534. Protocol UDP as the destination. So we got a source IP address range, we've got an RTP port range being allowed through the firewall to a destination which is a single IP address, or if the provider has several media IP addresses and the port numbers, we should be able to allow them through the firewall. Once we do this, it means our audio is going to be able to go all the way through to the bank. If you say something, the banker will hear us. So when the banker replies, we are supposed to allow the reverse should be true on the file. We should be able to allow now traffic coming into our network with source IP 167.168.1.12 on any port from this range. To 65534. We should be able to allow them on the file if they are destined to the LAN, to these IP addresses as destination 168.1.3 up to 254 on ports 5000 to 5511, so that the reply from the bank can be able to come through and be heard on the phone. But if we don't allow this here, we are also going to have one-way audio. Okay, moving on. So once we are saying number one, we should be able to put forward the microcontroller on port 5060 to the service provider port 5060 also. This is the provider IP for signaling, protocol UDP, and we are forwarding here to the Mitel controller IP address on the LAN, and also removing it and replacing it with the public IP address of the file when necessary. And number two, we should be able to allow, this is not port forwarding, allow the LAN IPs for the phones and port ranges to the port ranges of the provider media IP and ranges and port range and vice versa for the return traffic. And then to be able to change this IP address, the private IP address, to the public IP address of the file, we will make use of SIP ALG, application layer gateway. So what it then means is that on the firewall, as number 3, you must enable SIP ALG and test. If calls are successful and there is audio, you keep the SIP ALG enabled. If you test and then there is challenge with audio, go ahead and disable SIP ALG and test. If it works fine whilst SIP ALG is disabled, then keep it disabled. Hopefully this clears your mind. You understand what needs to be done on the file in relation to connecting a SIP trunk, especially to the BTC SIP provider. If we keep these 3 items in mind, which is port forwarding, allowing the LAN, and SIP ALG, if we manage to configure those accordingly, those 3 items, we will not have challenges with audio at all. That is all for now. Thank you for watching.